All right. Today we've got a quick informal, well, not informal, but just for the current situation, we've got this video to do a few examples of the intro to momentum charts worksheet. Okay. So this isn't the whole momentum chart problem. This is just like the beginning of it because it's important to know how to do one of these charts because the whole thing consists of three, right? You've got the initial momentum, the impulse, and then you've also got equals to the final momentum, right? So we want to know how to do at least one of them before we do a whole one, okay? So I'll do one, and I think I'm going to do number 6 as an example in this screencast. Okay, so again, first thing is first, we want to first just take note of the fact that momentum is equal to mass times velocity. Okay, so here you'll see that we've got our chart here. It looks like our LOL diagram one there, right? But since momentum has, well, not has to be, but can be negative, we've got to add like a negative region there too, right? So that's why that's there. Okay. Now here we've got the mass axis, and up and down we've got the velocity axis. So just keep in mind that's going to help you understand where to put each thing. Okay. So in this handout here we've got the mass. So it looks like we're talking about a bowling ball. So there's your bowling ball. It's got a mass of 6 kilograms. Okay. And we want to write down its velocity. So here we're told the speed, but a velocity also has a sign, right? So we know the speed is 2 meters per second. Which direction though? Positive or negative? Huh? Okay, so are we going to go up here 2 meters per second or down here 2 meters per second? Right? Positive or negative? Okay, so it turns out that for this one, it's moving to the right. Okay, so we want that top one, right? So let me get rid of the down one real quick. And here's how you make our rectangles, okay? So we've got a mass of 6. This time we're lucky. You're not always going to be so lucky, but we're going to go as far as 6. We're lucky because we've got nice numbers and we can fit in 6 boxes there. So you always want to label 6 kilograms here. And then we're going to build our rectangle upwards all the way to 2. And then just make it a rectangle. Boom. Okay. So our momentum is the area, right? So momentum is equal to base times height. It's mass times velocity. Okay. So when you do your mass is 6 times your velocity is 2 meters per second, then we get 12 for our momentum. Of course, I'm going to put units because that's what we do in science. We need to have units. Okay, so let's get over to number 6. All right, so I chose number 6 just because I want to show you an example where the numbers aren't going to always be so nice. And I also chose 6 because it's an impulse graph, okay, or an impulse chart rather. Now, impulse is equal to the force times time, right? Okay, and that's the reason why impulse is the reason why objects will change their momentum. They have to experience a force for a certain period of time. Okay, so very similar to the last example, we want to figure out what force we're talking about. So here the problem tells us this number 187,500 newtons there. And then we've got the time, so that's 20 seconds. So we're going to go 20 seconds here. Okay. So very similar to before, right? Except the difference with a momentum chart and an impulse chart is on an impulse chart, you've got time on the horizontal axis and then force on the y-axis. Okay, so what do you do if you're dealing with weird numbers like this? Here we've got huge numbers, and we don't have that many boxes, of course. And then you also have to be ready for what if I give you decimals, right? Okay, that's the thing that's going to happen. So this is where you're just going to label Okay, there's no great way around it. Okay, so on the time axis, we're gonna put 20 seconds. You have to label, okay, because if I'm grading this when we get back, I want to be able to see, you know, where you're where you're thinking. Okay, so you're going to label for me. Just write somewhere. Go right up here. Just tell me the height of this rectangle. Okay, so that's the impulse. Okay, now in order to get the area of this, I have it already done out in a calculator next to me. When you multiply these two numbers together to get the area, what we have here is 3,750,000 and then 3 zeros for impulse. And again, impulse doesn't have any fancy units, so it's just newtons times seconds. Okay, so again, is a positive impulse because that rectangle is up here. Okay, if I said something like the force was downward, then you would have built down here. Okay, so there's some examples like that somewhere between 2 and 5 where you have some negative ones. Okay, so hopefully these two examples help, and we'll talk more about these tomorrow. I'll see you in class.